Okay, let's dive right into this. Most students lose easy marks on cloud computing, but after this, you won't. Now listen, that isn't just some casual, off-the-cuff observation. That is a direct, word-for-word warning pulled straight from the Principal Examiner Report for Cambridge Computer Science. When it comes to the 9618 syllabus, and particularly the deeply technical, often misunderstood subject of cloud computing and the intricate differences between public and private clouds, examiners are seeing the exact same mistakes year after year after year. Literally thousands of highly capable students are leaving incredibly attainable marks just sitting there on the table. And why is that? Well, it's because they actually understand the technology, but they completely and utterly misunderstand the assessment itself. But hey, you're here, which means you are not going to be one of them. We're going to fix that exact problem immediately. Welcome to what I like to call the surgical theater. This explainer is your absolute ultimate insider playbook for dissecting Cambridge 9618 past papers with surgical accuracy. And honestly, whether you're building foundational skills in syllabuses like 0417, 0478, 0983, 0984, or 2210, or you're tackling the absolute beast that is the 9618 advanced level, the strategy is the same. Think of your exam paper as a patient right there on the operating table. You cannot just hack away with random facts you memorized the night before. You need precision instruments. You need incredibly steady hands. You have to know exactly where to make the cut to extract the absolute maximum amount of marks. Today, we are transforming you from a passive student into an active, highly strategic exam surgeon. We're going straight to the heart of cloud computing, and we are going to decode the exact mechanics of how those marks are actually awarded. So, here is our roadmap for today's procedure. First, we'll establish the core principles. Then, we'll introduce the procedural framework. Next, we'll dive into critical analysis, hit an interactive workshop, and finally, we'll reveal the top 3 mistakes to build your ultimate exam strategy. Let's get to work. Right, let's kick things off with Section 1, Core Principles and the Distinct Challenge of Cloud Computing Assessment. Now, you might be wondering, what exactly are examiners looking for? Well, the academic benchmarks for evaluating public and private clouds require intensely logical, structured reasoning. The Cambridge framework heavily prioritizes analytical depth over superficial breadth. Let's break the fourth wall here for a second and look through the eyes of a senior examiner at 2 highly capable yet fundamentally flawed students. First up, we have Alex. Now, Alex has basically swallowed the textbook whole. When asked to evaluate a cloud migration for, let's say, a hospital, Alex overloads the answer with raw, completely disconnected facts about public cloud scalability and private cloud data sovereignty. There's absolutely zero logical, structured reasoning applied to the specific hospital scenario. It's just a giant fact dump. Then, on the other side, we have Sam. Sam actually understands the context, but totally rushes the execution. Sam misses the distinct command words, words like evaluate or analyze, and just gives us really brief, superficial recommendation without diving into the required cognitive domains of application. And guess what? Both of these students leave half their marks behind because they just fail to meet the academic benchmarks of systematic analysis. Moving right along to Section 2, the procedural framework. Now, what's really interesting about this slide is that this is where we strip away all the mystery of grading and look at the bare, underlying mechanics of the Cambridge mark scheme. We need to talk about the method mark strategy. This is an assessment framework where examiners award marks for your step-by-step analytical process, your logical reasoning, and your clear working, rather than just jumping straight to your final conclusion. Listen, in a complex cloud computing question, simply concluding that a hybrid cloud is the best choice is worth almost nothing on its own. The marks are heavily weighted on exactly how you got there. Did you apply systematic analysis? Did you demonstrate evidence-based reasoning? Did you show your working? Algorithmic thinking isn't just for coding, guys. It applies directly to writing your theoretical answers too. Showing your logical steps is absolutely paramount. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. So, how do we actually guarantee those method marks? We do it by adapting a highly systematic processing sequence. If you've ever heard of the Peel framework in English, point, evidence, explanation, link, well, this is its highly technical older brother, perfectly tailored for computer science. Step 1. Identify key elements. You literally deconstruct the question constraints. What are they asking? Step 2. Apply relevant principles. Which cloud deployment model actually fits this specific scenario? Step 3. Execute analysis. This is where your algorithmic thinking really shines through via step-by-step decomposition of the problem. You break it down. Step 4. Verify results. Have you actually addressed all the constraints of the prompt, or did you go off on a tangent? And finally, step 5. Present in format. delivering it all with the appropriate high-level terminology and data structures. It is a repeatable, completely unbreakable algorithm for scoring. Let's move to Section 3, critical analysis, and see how this builds. Because it's one thing to understand the theory of step-by-step decomposition, it is an entirely different beast to actually apply it when you're sitting under the harsh fluorescent lights of an exam hall.
Take a look at this generic, incredibly flawed answer that simply lists basic public cloud facts. Public clouds are cheaper and easier to scale. Boom! That gets a red pen right across it because it completely lacks context. Now, compare that to a top-scoring candidate who demonstrates rigorous, evaluative thinking by writing something like, while a public cloud offers superior scalability to handle unpredictable traffic spikes, the strict data compliance laws governing this specific financial institution necessitates the isolated infrastructure of a private cloud. See the difference? They analyzed the trade-offs, they justified their decisions with concrete evidence, they even evaluated the system's space and time complexity equivalence by discussing processing latency and storage limits. That is exactly how you secure those top marks. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, Section 4, the interactive workshop. Crack your knuckles because it is time to put your surgical skills to the test with 3 rapid-fire challenges based on real Cambridge source material. Get your mental timers ready because in the actual exam, the clock is quite literally your biggest adversary. Okay, Challenge 1, the data scan. Imagine a 60-second timer ticking down right now. Your job isn't to casually read every single word of the data presented in this table. Your job is to extract the core analytical trend. What is the fundamental trade-off between public and private clouds regarding resource allocation and testing rigor? Top candidates use comparative connectives. They don't just state isolated facts. They say things like, whereas public cloud resource allocation is highly elastic, it demands distinctly different data structure optimization compared to a private cloud, which offers rigid allocation but allows for much deeper native testing rigor. You absolutely must identify similarities and differences, and you have to support each single one with evidence from the data. Moving on to Challenge 2. Find the flaw. Consider a student who writes a paragraph mentioning migrating to a public cloud and then just boldly states that performance improved. What exactly is losing the marks here? Well, first off, they provide absolutely zero evidence. Second, they fail entirely to acknowledge the inherent limitations of the technology, things like potential vendor lock-in or shared tenancy latency spikes. But worst of all, they completely ignore edge cases. What happens when the internet connection drops? Top examiners specifically note that evaluating the quality of any cloud solution requires identifying edge cases and their direct effect on performance. If you're not doing that, you are literally bleeding marks on the page. And now, Challenge 3, speed writing. We are doing a 30-second mental sprint. If you were handed a blank page right now, this very second, and asked to evaluate cloud performance limits, how do you start? You need those precision instruments and steady hands. First sentence, that's your point, grounded perfectly in the context of the question. Second sentence, your evidence, naming a very specific hardware or network limitation. Third sentence, your explanation of exactly how that limits algorithmic efficiency. And the final sentence, link it back to the overarching business impact. That right there is the step-by-step procedural framework in action. If you can draft that mentally in 30 seconds, you are genuinely ready. So, the crucial point is coming up here in Section 5, Top 3 Mistakes and Exam Strategy, because understanding the theory is really only half the battle. Avoiding the wildly predictable pitfalls is the rest of the war. Let's look at the top errors and formalize your ultimate exam strategy. Pay incredibly close attention because these are the official examiner alerts directly from the Cambridge Principal Examiner reports. Mistake number 1, confusing cause and effect. Students constantly and incorrectly state that moving to a public cloud causes better algorithmic performance. It doesn't. It merely provides scalable infrastructure. The underlying algorithm's time complexity remains exactly the same. Mistake number 2, forgetting boundary conditions and edge cases. You have to test the extremes of the cloud deployment. What actually happens at peak concurrent user load? Does it crash? Does it bottleneck? And mistake number 3, the absolute ultimate classic error, providing generic answers. If the question is about a local neighborhood pharmacy and you write a beautiful generic essay about public clouds without once mentioning patient data security or prescription databases, you will score a flat 0 for application. Always, always link every single point to the specific scenario they gave you. Now, under the intense pressure of a ticking clock, it is so easy to forget this framework. So here is a highly actionable memory hack. Create a custom mnemonic using the first letters of the key terms we've discussed today. For example, for critical cloud analysis, you can use the acronym TSEE. That stands for time complexity, space complexity, edge cases, and effect on performance. TSEE. Or to remember the procedural framework itself, identify, apply, execute, verify, present. IAEVP. You need to lock this into your brain. The very second you sit down and turn over the exam paper, write your mnemonic at the top of the page. It becomes your anchor, ensuring you systematically process the question without panicking, no matter what they throw at you.
So here it is, the final computer science success blueprint. This is the culmination of everything we've covered. Step 1. Deconstruct the question and underline the exact command words. Step 2. Extract relevant data from the specific scenario provided. Step 3. Select your analytical framework. Are we comparing public versus private, or evaluating a single deployment? Step 4. Execute with clear notation, showing every logical step to capture those crucial method marks. And Step 5, present your conclusion with correct, high-level terminology. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. I want to leave you with this one provocative question to challenge your readiness. As you sit down to study tonight, look at your past papers and ask yourself honestly, are your answers truly context-specific, proving you deeply understand the unique technical constraints of the scenario? Or are you just repeating generic textbook definitions, hoping the examiner is feeling generous? The difference between the two is literally the difference between an average grade and an absolute top-tier mark. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.